Hello everyone, this is Tiago from Coderversity, and in today's video I'm going to be teaching you the .NET 8 crash course for beginner and intermediate developers. Today you will learn how to set up a project, how is the .NET project structure like, some C# fundamentals, what is object-oriented programming, also known as OOO, working and using .NET libraries, some C# intermediate topics, and finally how to build a web API. The technologies for this are C#, .NET 8 and Entity Framework Core 8. So what are you waiting for? Let's dive in. Let's start by installing the .NET 8 SDK. The .NET 8 SDK is a software development kit that includes the tools required to develop and run .NET applications. Let's check the page where we can download this. So here, if you have a Mac, you can download the SDK for Mac, or if you have a Mac with Intel chip or a Windows, you can also download here for the SDK. Don't worry, we will have this in the description. And also, you will need the Postman. The Postman is an application that simulates HTTP calls. This will be useful later for our API. So stay tuned. Let's begin with creating the project. We will need a web API. I'm using the Visual Studio Code, that is an IDE. An IDE is an integrated development environment, like Visual Studio or this one, Visual Studio Code, and provides essential features such as code editing, debugging, and project management. So let's create our app. I'm going to create it in the desktop, and let's do a zoo simulator. Let's create the project. Okay, now let's understand a bit of the .NET structure. So here we have the program.cs. The program.cs is the file where the entry point of a .NET application is. Typically contains the main method where the program starts execution. But in .NET 8, the structure can be simplified with top-level statement, removing the need for a traditional main method, like you can see here. Then we have the project files and directories. For example, here the properties contain the project metadata. Also, we have here the app settings.json, which stores configuration settings in ASP.NET Core projects. We can also have a startup or program.cs, that is this one, which you can config services and middleware. And finally, the CS proj, which define the project dependencies and build settings. So let's start. We will use object-oriented programming. Object-oriented programming is a way of programming that revolves around classes, which are blueprints for creating object instances for those classes. So, for example, let's say you have an animal. An animal is a bit abstract, right? It's very generic. So you can have a dog, you can have a cat, you can have multiple animals. So let's say that we have the animal dog, and our class will be called dog. What is a class? Imagine that you are baking a cake. You use like forms, right, to the cake, and once you put the ingredients, that will be the properties of the class, you will put it into the oven and multiple objects of the same type will come out, right? So if you are cooking cookies, you will put multiple ingredients on multiple forms in order to be always the same kind of cookie come out. It's the same thing with the classes. If you have a class named dog with properties like name or the way he moves, and you instantiate multiple times, you are creating multiple objects of the dog. You can think of the dog as the oven and the instances as the cookies. So let's begin with the code. Let's start by creating our domain. What is our domain? Our domain is where our classes will be stored. The classes are our domain, where the business rules stand. So let's call an animal.cs. The files for CSharp always have the .cs extension. I will create a public abstract animal. Now, what is the abstract? Abstract is an access modifier, and access modifiers control who can see and use your code, like variables and methods. Think of them as levels of privacy. Like the public, anyone can access it. It's like having a public phone number anyone can call. So I can declare here like public instead of abstract. Then we have the private, when only the code inside the same class can access it. It's like having a personal journal where no one else can read. Then we have the protected, where only the class and its child classes, derived classes that we will see in a minute, can access it. It's like a family secret shared with only your family. Then we have the protected internal, a combination of protected and internal accessible by classes in the same assembly or derived classes. Then we have the private protected, accessible only within the same class or in derived class that are in the same assembly. What is abstract though? Abstract is it's like the concept says, it's nothing like you can define, nothing that you can instantiate. It's abstract. So why am I declaring animal as abstract? Because when we add an animal to the zoo, we want to add a specific animal. So we want the animal class to have all the common properties that an animal has. So for example, a name like a tiger or a lion or an eagle, and let's say a movement type. These are common to all kinds of animals. So that's what an abstract class is for. So when we instantiate classes that will inherit from the class animal, we want them to have initially a movement type and a name. The movement type will be an enum, and for that we will create a cross-cutting layer. The cross-cutting layer is common and accessible through all the projects, through an onion architecture, that is. If you want to check more, please search and check out one of my videos for the grocery basket simulator when I explain a bit better. So let's type in movement type.cs. Let's declare it as public enum movement type. In the movement type, we want, let's simplify and have two enumerations: walking and flying. Let's keep it simple. Okay. So now let's give it the properties. So we will have these stored in a database, and to have distinction between objects, we have to declare a property that will be unique for each of them. So let's declare it as an ID property. And then we will have this. This is a type of variable. A type of variable can vary. So this is an int representing an integer, a 32-bit signed integer, as you can see. This, as this one, we have the boolean as well. For example, these are called the value type. Why is it value type? Because in the computer memory, this is allocated directly to the memory. So let's imagine we have a list of variables and the int is stored directly. So when we want to access it, we access directly to the place of the memory where this is. There are other types like a string, for example. A string represents text and you can declare it like this. And it's a reference type. What does it mean to be a reference type? On the contrary of the integer, that is a value type and is stored directly into memory, the string will have a reference to the place of the memory. So, like an address where you can see where it lives actually. So let's declare the ID. Declare the ID, we will put a get. This means that we will have a public method that we can access the ID outside of the class. And since we don't want the ID to change outside the class, let's set it to private. Then we will have a name that will be a string since it contains text. But just a parenthesis here. So there is a concept in object-oriented programming that is very important that is called encapsulation. What does this mean? So encapsulation is like a capsule where you don't want others to access it without your consent, let's say. So if this is public, can be accessed publicly, and we want this to be very restricted and want specific values or business rules to be made in order for this to be set. So we will actually make a private field where it can only be accessed by the own class, and the first time an animal is instantiated will be instantiated with the string that we pass, called name here in the constructor. A constructor is like a gateway for creating instances. And then we need, if we want to change on the public side, we will declare a string name, but with a twist. Let's add here our getter, that this is called a getter, a method to get, that will retrieve us the value of our private property. But our set will be private, which means publicly we don't have access direct access actually to the field that has the value, since it's private, and we have a private set, which means that we want here that our core, let's say like that, field will have the value that we pass on the set later. So when we say, for example, later name equals Josh, for example, he will call always the setter, because with equal we are doing an attribution to the variable. And with this, since this is public, this is the only way the public can access the name. So it will have automatically to pass by this set. And here we can apply business logic that we want mandatorily to be ran every time it is publicly set. So if it is set outside, it will always pass through our business logic, and we can make here validations to check if the input is correct, etc, etc. That's why the encapsulation is important. Then we'll do the same thing but for movement type. Movement type, and let's initialize the first time the instance is created, the cookie, so to speak. And then we will have the get, we'll retrieve not the name, movement type, and our private set that will set the movement type equals to the value. And also we can also add business logic here. This is a comment. The code will ignore this. This is just for the developer. Okay. Now then, we want the animals to have a name, a movement type, and to make a sound. But the sound will be different and can be overridden by each animal. So a tiger does a sound, a lion does a different sound, an eagle does a different sound, which means that we can do a method in the parent class that will be animal, which the tiger and the other animals will inherit from, and we will get there to the more detailed explanation, don't worry. And we put virtual. What does virtual mean? Virtual means that the method can be overridden with the code that we set in the child classes of the animal. Let's put our hands into work to see the things more clearly. Void means that the method doesn't work, doesn't return anything. So what is a method? A method is a block of code that can be reused in the class or in the other classes. This is very useful not to have code repeated and to readability. So let's call it make sound. And then we put to the console write line, and let's insert the default that will be silence. This is a lambda expression. We can also this as another way of implementing, that is the typical way, the traditional way, that is this, that can have multiple lines of code. So like var int equals 1, not var int, var x equals 1, and return, etc. But the lambda has always the return in the first line, the return or the output, let's say like that. You can't have multiple lines of code in a lambda expression unless you put the brackets, of course. This is sugar syntax, as we say. So the functionality doesn't change, but it's more readable and more pretty. So now we have the animals, and we want to inherit this information because an animal can be multiple things. So let's do an eagle. An eagle will be a public class called eagle, and the animal constructor, that is the gateway to instantiate the animal, always requires a movement type and a string name. So, and since this is abstract, we will have to inherit this from the child classes. So movement type and string Actually, let's not pass like this. To inherit the properties and the methods of that are not private to the class, of course, of a class, we just type in 2 dots and in this case animal. And we want to pass what does the animal need, the movement type and the string name to be instantiated. So let's pass the movement type that we receive in the eagle and the name, so we can put the name of the class, which can be like this, name of, and then we put the class. So that when we change the class name, for example, it reflects here as well. If we put a string, for example, we can change the class, but for example, tiger, but it will accept anyway the, if we put like this instead the name of, it will accept and it will be wrong. And if it's like this, it will be wrong because there is no eagle. So let's keep it safe. This, by the way, was introduced in .NET 8 called a primary constructor. There is another way of doing this. That is, we declare a class here, and then we declare the constructor inside, where we have to type in again class eagle movement type, move type, and then we put here like base movement type, and then the name of the class, and we close the brackets. This is the same thing, but this way we keep it more readable and more simple. So now do you remember that in the animal we had these sounds that will be unique for each animal? We declared it virtual, which means we can override it. So let's do it. Public override void make sound, and then we can do console.writeLine that will output the text that we put here, and instead of the silence that we'll have here, we will have a screech, typical of eagles. Screech. Okay. Now you noticed that, by the way, this overridden, now when we say to the eagle to make a sound, she will, instead of making the sound of the parent class, she will make her own sound, that overridden. So now I believe you noticed we don't have any properties here, like our movement type or our name, and that is because it inherits from the animal. And that's why it's important to have a parent class. This is called inheritance. Inheritance checks actually saves the common properties between the child classes so that you don't have to declare them multiple times. And there is another thing related to inheritance that is called polymorphism. So an eagle can also be declared as an animal. So for example, if we instantiate, and this is how you instantiate eagle e, and then you call the constructor, that is new eagle movement type dot flying, we choose this enum that we declared early here. It will call this constructor and pass these properties to our parent class and store it here. That we will have access through the eagle as well, since it's an animal, like it says here. This is how you instantiate. So we are making a sound, and now let's do the same thing for other two animals. Let's put a tiger.cs, let's copy paste and put here tiger, and let's edit the sound for a roar. And finally, we will have a lion. And the lion will, of course, have a roar. There, we have our domain ready. So now, what do we need? In the domain the domain actually will be represented by a table in the database. And for that, I will use Docker to run an SQL Server image since I'm using a Mac, and I will use Azure Data Studio, and as you can see, I've already created the animals table. If you want to know more details about this and how to work with this Docker, SQL Server and Entity Framework core with .NET 8, check out the video in the description that I will put. Now that the table is created, let's make a way of accessing it in our data layer. So our data layer will be called the repository layer. So let's call it repositories and add the animal repo.cs. We will declare it as public class animal repo, and for that, for the connection between our entities and our database, we will use Entity Framework Core. Entity Framework Core is an ORM, an Object Relational Mapping tool that is built specifically to map entities to tables and to facilitate the work for developers to map that. So the Entity Framework Core always has a context in which we work on, and we will inherit of animal repo. And what is the iAnimal repo? iAnimal repo is an interface that I will create. So an interface is like a contract that you have to respect. So public interface iAnimal repo. And the contract says which methods you have to implement. So it's really a contract. So if you put that in the interface, wherever classes that implements the interface, that like this, it's like inheritance, and we'll have to implement that. But we will only have the signatures for the methods in the interface. So let's put, we will have a list of animal, and we will retrieve all animals in the zoo asynchronously. Now, what is this task and async that I just put in there? So in CSharp, async and await are key components for asynchronous programming. They are used to work with tasks and make code more efficient by allowing the program to run multiple operations simultaneously without blocking the main thread. This async keyword, so whenever you put in a task and you want to implement, you want to have the same signature and public, but we have to have not the await, the async keyword. The async keyword is used to declare a method that contains an asynchronous operation. when a method is marked with async, like this one, it can use the await keyword inside its body. An async method typically returns one of the following items: either the task, for methods that don't return a value, like this type, or a task with a type, in this case, list of animals. That for methods that return a value type, not a value type, that return a type of this value. In this case, a list of animals. Now, the await keyword. So, in order to show you the asynchronous and task await and async keywords, let me show you an example. Let's simulate a delay from our repo to a database of like half a second. So we put await and the task.delay milliseconds. This is in milliseconds. So when we call this get all animals async, we always delay for half a second, and we have to wait for this task to be completed. The same way we will have to await whenever we will call this get animals async. This is just to show you how you can put it in practice. So the await keyword is used inside an async method to indicate that the program should asynchronously wait for the completion of a task. When the await keyword is used, the control is returned to the caller method until the awaited task is complete without blocking the execution. So, for example, imagine that we have multiple tasks in this thread. Let's say that we have another method somewhere that we can access, like this get all animals async that is asynchronous. We could put like await. This is just an example, illustrative example. Get all animals async. This will wait for this task to be completed. But now let's imagine we have another one called get all tigers async. These are two tasks. Now let's imagine that we want to make a calculation, for example, like var x equals 1 plus 5 or another more complex operation. And we don't want this specific assignation to only run when these tasks are done, because we are putting the keyword await. So we can do var task2 equals this and var task1 equals this. This is just figuratively, so ignore the errors. We can do task dot when all. We can put here an array. Actually, let's put new. Let's declare a new array where we have the task1 and the task2. So what will this do? This, although the tasks are already running, we don't have to wait for them to finish. We can do this operation and then we do whatever code we put here only after these two tasks are completed. So this is a really good advantage of the asynchronous programming. So back to the original thread. So now we have our methods declared, our method in this case. So let's put animals equals, and we have to figure out this error, right? So we are going to use, like I said before, Entity Framework Core. But Entity Framework Core is a library. And what is a library? Library is a program or a resource that we can pack. Let's say we develop this project, and then we can pack into a nugget package so that other people in other projects can reuse it. And for the Entity Framework core, we need to install that package that someone else did, in this case Microsoft. So to install the package into our project, we have to put .NET add package and then Microsoft Entity Framework core. We have to go in the Zoo Simulator folder and run again. Don't worry, every command and every link will be in the description in the end of the video. So now it is installed, but that is not enough. In order for this not to be used and applied to the whole project, because that would be heavy, we put using Microsoft.Entity Framework core. And now we have an app DB context. So in here, app DB contexts. Oh, of course, because this we will have to first declare here our app DB context to make our own rules and use the DB context from Entity Framework in here and not in here. So let's create the DB context. Public class app DB context that will inherit from DB context. Always, every time that we say that some class inherits from another, we can say that this class is this as well. So for example, a tiger is an animal, a lion is an animal, an eagle is an animal. And in the same way, our custom class, our app DB context, will be a DB context from the Microsoft Entity Framework package. For that, we will need a DB set. And again, if you want to know more about Entity Framework core, please visit the link that I put in the description for my previous video. Animals. We are making here a connection from between our entities and the database table. Public app DB context, DB context options, app DB context. This is always declared the same way when we work with Entity Framework core, and this means that we are passing this parameter from our constructor to the base class constructor. And now we have to, according to the documentation of Microsoft, we have to override like we did in the eagle and the tiger and the lion. Here we have the same thing for caps lock. We have the same thing for on model creating, which means when we are creating a model here, it will override the base class model and we are making our own rules. So in Entity Framework core, this is the pattern. Now let's put on rules. We'll use the model builder for our entity animal. But we can't instantiate animals, right? It is abstract, so we can't instantiate. So we have here to add a discriminator. So What is a discriminator? A discriminator is a column in the table that Entity Framework Core uses to determine the specific subclass, in this case the child classes, of an entity when querying data. The function for this is when you query the database, Entity Framework Core uses a discriminator column to filter and instantiate the correct subclass. So for example, our table has animals, but it doesn't know, it has no way to know if it's a tiger or if it's an eagle. So let's use a discriminator and use the name for that, since we are using the name based on the class. So we add here as discriminator of type string. Usually this diamond operator indicates the type that we want to use. So we'll use the property name, the discriminator name, and we have the value for lion. We'll have name of lion, and let's do the same thing for the tiger and for the eagle. Now we have our discriminator. Now, since our movement type is an enum, it is not text, right? So the database is set as text and varchar is text. So how will we make this conversion? We go here to model builder again and set a rule for the entity animal and we say that the property, and we use a lambda expression, that the movement type has a conversion to string. So when he detects a string, we are storing. When he detects an enum, he stores as string, and when we read, we cast the type, so we change the type from string to enum, so we try to parse the enum, and for that we need the enum type that we can get by putting the type of, and then we put movement type, and then the v, and then this converts back to string, back to enum when we parse. Now, one last thing, do you remember? We put the ID as a primary key, so it means this is the identifier and is unique. So we have to declare that as well, so that entity framework knows. So we do model builder dot entity, and for lion we map to the table animals. But before that, as I was saying, we do model builder dot entity animal, and we say that it has a key, and the animal has the key ID represented by the ID, and we have to say that each entity maps to the table animals. So model builder entity lion to table animals. maybe we need here other package to work with SQL Server. SQL Server is a technology for the databases. That is a sub-package of the Entity Framework Core. So let's do this again. Package Microsoft Entity Framework Core.SQL Server. And let's use again .SQL Server. And now we have the table. Actually, we don't even need this. Okay, so let's do the same for the other animals. So the tiger and the eagle. They will all be mapped to this table according to the rules we just put in here. So now we have the animal repo, like we were saying, and we will implement the methods. But before that, let's put the full contract on. So for our API, we will need the get animals asynchronously, and then let's keep it simple and keep using synchronous programming. So let's try to get animals by movement type. Movement type. And now we don't want to return anything, and let's add an animal to the zoo. And lastly, let's have a method to check if the animal exists or not. And we will check it by name. So now, since this is an interface, we have to respect the contract. And this is not only to make the concrete classes to implement these methods, but is also useful for dependency injection, maintainability, and testing that we will see later. So now let's implement it. First, to get all animals async. Let's start with that. So animals, we will have to get the context, since the context will go to our database, and then we will put to context of animals, because our DB context has our DB set called animals, and then we want a toList, because this is LINQ. I will explain what LINQ is, and I will also put in the description a link for the documentation that looks something like this. This is the Microsoft page. We have the getting started with LINQ and the start at query operators and how to articles. So LINQ stands for Language Integrated Query, and is a powerful querying tool in CSharp that allows you to query and manipulate data from various data sources like collections, databases, XML documents, and more. LINQ provides a consistent model for working with data across different kinds of data resources and formats. The key concepts of LINQ are query expressions. LINQ queries can be written using query syntax, which resembles SQL from the database, or method syntax using extension methods. These queries can be executed against the type interface any IEnumerable or IQueryable data sources. So let's use it. So we have a context and we have an animals, and we know that animals are DB sets. Let's let's use LINQ to order by, to order by, and let's order by name. LINQ is very powerful and has multiple resources, but you can check it later in the project and also in the documentation. So to retrieve all the animals, we will just do this, and then we can return like this. We just return the variable. So next we will have in the contract is get animals by the movement type. So public and it's void, like it says in the contract, the interface, and not void, it's actually a list. Yeah, a list of animal, and get animals by movement type. And then you receive by parameter the movement type we want to search and use it here. So again, we will store the animals returned in this variable. When you don't know the type or there is a standard to declare variables, you can just type in var in .NET. You can also do like this, for example, for other examples, but let's do it like this. So let's go to the context again, and then to the animals, and then we want a specific condition, and let's use LINQ for that, where our animals dot movement type are equal to the movement type that we want and receive by parameter. And LINQ makes use of the collection and enumerates the collection after we put to list or to array or any kind of concrete of collection. So don't forget to do this if you are not going to work with the list anymore. And now we return the animals. Pretty cool. Next on the list is the add animal to the zoo, and it's void, which means that it doesn't return anything, any value. So add animal to zoo, and we receive an animal. And here we are using the polymorphism. We are using the abstract class, but the color of this method can pass an eagle or a tiger or a lion, for example, because it will interpret that is an animal. It will cast it is possible to be used as an animal, and from animal to one of these that implements the parent class. This is called polymorphism. So now what we want to do is to get the context animals and add our animal. And then we want to commit the changes on the database, and for that we use the context.savechanges. And lastly, we will have a method that is very handy to check if the animal exists. And we will get by name. It's missing an S here. And now we will return if context.animals. And again, LINQ, very powerful. We will use a query from that. And if there is any animal in which, and this is how we compare strings. This is a method from the reference. This is a static method from the reference type string, because value types can't have other than properties. And the string method has a static method, which means you don't need an instance to call this method. So equals and then a.name to our name that we received by parameter. And if it detects, it will return true, and if doesn't detect, it will return false. Those are the possible values for Boolean, true or false. It's a binary answer. Okay, so now we have our repo, we have our interface, we have our entities. So now all we need is a service to be the mediator between our presentation layer and our repositories. I'm following a very basic onion architecture if you want to search more for it. Services. Again, I'm gonna define a contract for dependency injection that we will see in a second. I-zoo service. Usually, by default, the interfaces start with an I, so that we can distinguish better. Just a parenthesis here. And interfaces are a fundamental concept that in object-oriented programming that defines a contract or a set of methods and properties that implementing classes must provide, like we said before. Like, you can implement even multiple interfaces. So let's say an interface for walking, and the way of walking has a couple of methods, but an eagle can fly as well. So we will implement an interface that will have methods that only flying animals can handle. So you can have multiple contracts. Let's declare this one. I-zoo service. And then let's use asynchronous again, because we will call the same ones from the repo, but we can make an additional business rule in the service, and that's what the services are for. Get all animals from zoo async. Usually the asynchronous methods have async in the end, so that the developer knows better when to use async or not. Then we'll have a list of animals when we need to get our animals by movement type, which will search using our enum, and finally a bool add animal to zoo animal. And why did I choose a bool here as a return type? Because let's do the following. Let's try to add the animal in the zoo, but do you remember this method if animal exists? So we'll use in the service this method. So we'll check if the animal exists, we don't add, and if we don't add, it means it wasn't a successful addition, so we return false, otherwise we return true. Let's implement now. Let's declare the zoo service.cs. So public class zoo service, and we will use dependency injection. Now, what is dependency injection? Dependency injection is a design pattern and a core principle in software engineering, particularly in object-oriented programming, and to achieve inversion of control between classes and their dependencies. In simpler terms, DI allows for injecting dependencies, services, and objects into a class rather than the class creating them internally. This leads to more modular, testable, and maintainable code. The core concepts of dependency injection are dependency. A dependency in any object that another object requires to function. For example, if a class car, for example, needs an instance of engine to operate, engine is a dependency of car. And then injection. Injection is the process of passing the dependencies to a class instead of the class creating them. This can be done via constructor injection. That is what I'm doing now by passing the class and not the concrete class. We are passing just the contracts. And the contracts can be used by multiple different classes. So, and property injection, where the dependencies are set to public properties of the class, method injection, and some benefits of dependency injection are decoupling, where DI reduces the tight coupling between a class and its dependencies, making the code more flexible and easy to change. So for example, if you put here, like I put the interface, it means that you can use any class that respects this contract. Otherwise, if we just put animal repo, we can only use this concrete class. And this is not very useful for us and not very good practice. So decoupling reduces the dependency between entities, and it becomes easier to swap real implementations with mock objects or stubs during unit testing, for example. And since for testability, since the dependency are injected, it becomes easier to swap real implementations with mock objects, like I said before. And for maintainability, the DI project promotes single responsibility and adherence to the solid principle, particularly the dependency inversion principle, making the code base easier to maintain. And for that, to instantiate objects via dependency injection, we will have 3 different main life cycles that I will explain soon to you. So let's keep doing it. Animal repo. And now, like this, we can use the zoo service, but it is complaining that we do not implement the interface members that we declared, which means we are not doing the contract correctly because we didn't implement anything. So let's do the dependency injection. So for the dependency injection, we will go here to the program, and we insert the injection here. So we go to the builder of the project, services, and we add, let's say, a transient. What is a transient? A transient is one of the life cycles that I mentioned before. There are 3 types. The 3 types are transient, scoped, and finally the singleton. So the transient is like short-lived. And what does it mean? It means that a new instance of the service is created every time it's needed. So when to use? When the service doesn't need to remember anything, so it's stateless. For example, a service that just does a quick calculation. Example, think of a disposable cup. You use it once and then you throw it away. And then we have the scoped. The scoped, it lives during a request. Well, what does it mean? It means that the service is created once per request and reused within that request. It's useful in web applications where you want to keep track of the user data during a single page load. You can use it when you want the service to keep information while handling one request but throw it away afterward. And finally, we have the singleton that lives as long as the program, as the app is running. So what does it mean? The service is created once when the program starts and stays the same for the entire life of the program. You can use it when the service needs to remember things or it's expensive to create. So, for example, think of a refrigerator that you will use all the time and it keeps working for a long time. In this case, we will use transient. And the way to do that is we want to, in this case, we just have one contract for one class, and in this case, the iAnimal repo will instantiate the animal repo concrete class. And the same thing for the iZoo service. Now we have our dependency injection set. So let's go to our service again and let's implement the methods. So we have a private iAnimal repo because we want to use the repo via service, so we want to keep the repo private to the service. We don't want the user to interact directly with the repo. We use service for that. And animal repo that will use the dependency injection animal repo, and this is how you declare it. You put in the interface and you declare a property and you initialize. Again, I'm using primary constructor from .NET 8. By the way, a thing that I didn't mention earlier, the LINQ was awesomely improved in .NET 8. Just an FYI. Public async task. Let's implement the methods. List of animal, where we get all animals from to async. Return, and we have to await the task. Animal get all animals async. And when we await the task, we are returning the content of the task. Otherwise, if we don't await, we return the task so that we can await later, like we did in the previous example of when all. Next, we have the return type list animals, and we want get animals by movements type. And then we return the animal repo method for get animals by movement type, and we pass the movement type received by parameter. We are here simply calling the repo, but if the business logic were more complex, we could add here business logic. That's the purpose of the service, like we will do right here. Add animal to zoo, animal, animal, and this is not the parentheses that I wanted the bracket, and we will use the repo method to check if the animal is animal present. I will check animal repo dot animal exists because it returns a boolean and uses the animal.name. And now, since it returns a boolean, we will hold the result here in this variable that will hold either true or false. So we now pass to the conditional checks. Conditional checks are conditions that you can control the flow, which you can use to control the flow of the program. So you only want to add the animal to the zoo if this is true, right? So if the animal is present, so we declare with this syntax, if is animal present. If we can do like this, or we can omit, because the boolean will interpret that this is equal to true. So, and since we only want to add if the animal is not present, how do we say that? We just negate the condition. So this is true, and with the exclamation mark means false. So if the animal is not present, then we go to the animal repo and add animal to zoo, and we pass the animal. And since it needs a boolean to know if the addition was successful or not, we return here true, because we add the animal to the zoo, and else, and on the other conditions that it's not this one, we return false. So we can put else return false. But there's a catch here. If it enters in here, it will return true. And if it returns true, it will ignore the rest of the program. So we don't need this else. We just do if this doesn't match, we just return false. There are other checks and loops like the else if. So let's imagine that this is not a boolean and it's another value with multiple possible outcomes that other than true or false. We can put else if and put another condition here. And we can do multiple times like this. And then we have the loops that we can iterate a list, for example. So we receive a list of animals and we want to iterate through it. We can either do a for each, where we declare a variable that will hold each value of each iteration of the list, in this case animal. Let's say we have a list animals. This is just an example. New list animal, and we have here, imagine that we have here multiple animals. We go for each variable that will hold each iteration value of this list in animals. We do our code here. We do what we want in each iteration. We can do the same thing with a for. So for int equals 0. This is the for each a bit more detailed. What does this mean? This means that the for is also a loop that will iterate through this index that will have the value 0 until while the I is less than the count of animals. So while it is lower than the entries in this list. So while the list has entries, we will iterate like the for each. And for each iteration, we want to iterate the I by by value 1. So this is the same thing as I plus 1. We are just iterating so that the next iteration, the I has the iteration 1. And then we can access like this, animals, and we can use the number of the index, like this. And there you have the loops. There's also the while a condition. You can do your code here, which means it will execute your code every time. So it will execute your code once, then checks the condition. Condition is true, yes. Then it runs the code again, condition is false, yes, it's false, then it doesn't run the code anymore. So there you have it, the loops. Now, back to where we were. Now we have the service all implemented. Now we need to use it. So let's go to the program. This is the program that was generated automatically when we created the project. And let's talk about middlewares. What is a middleware? A middleware is a software that bridges the gap between applications and operating systems by providing under the curtain logic. So this capability is useful for applications that otherwise do not have any way to exchange data with other software tools or databases. So for example, let's write a middleware that will log every request made to our API, helping in debugging and monitoring. So let's do it. The way we declare it has two ways we can use. We can do like this, and allow the function, so it is asynchronous. And then we do our code. Since it's a lambda and we want more than one line of code, we put the brackets. So for logging, let's output to the log, to the console. A request. And we use this $sign in order to use variables inside the string. Otherwise, it will interpret that is text and not the name of a variable. So request, and then we put the variable between brackets, and then we need the app context. Then we go to the request and then method. This will be useful for logging, for debugging, and then the context.request.path to check what we are doing in the API. Then we will await for the next request, and then this within the context of the app, and then we will write line the response of our requests, and we'll have to access the context.response.status code, for example. There we go, we have a middleware. And if you want a bit more complex middleware or declare it in another class and use it here, we can also do it. There's also another way. So imagine like this: public class. So actually, let's declare here in the cross-cutting logging middleware. Public class request. Logging middleware. And we will a private read-only. This is always like this. The read-only keyword means that it can only change value when instantiated in the constructor, and then it's immutable, won't change. Just follow this structure. Delegate. To create a middleware. A delegate is a function that you can pass like a variable, like this function for example, and you can pass like a parameter so that another method knows that you will use that block of code. That is a delegate. And then we have the constructor. We could also use the primary constructor, of course, and then for it to be invoked behind the curtains, we need to make it asynchronous and a task without any return type, and call a method called invoke async, so it can be invoked within the HTTP context. And then we just put the same code that we had, and let's eliminate this, put here, next, and we need the context, and there we go. We have our own middleware. Now we can just register it, and we can do it by just putting app.use middleware and our middleware, and voila, you created your own middleware. Now this is a minimal API. What is a minimal API? .NET Minimal API is a feature that was introduced in .NET 8 and improved in .NET 6 actually, and improved in later versions, designed to simplify the development of APIs. And the Minimal API is a simple way to create APIs without using .NET without the need for a lot of configuration or boilerplate code. The key features for this is the concise syntax. The APIs use a more concise syntax, allowing you to define endpoints and request handling logic directly in the program.cs like we are doing, and has an improved startup when the minimal API approach simplifies the startup configuration by reducing the need for multiple files and classes. So let's put our hands to work. Let's use what we had already. We don't need this. And we want our API to always start with animals. So we will use a zoo API and create a new group. Let's route a group. Routing an API is like the mailman when he delivers the mail to everyone in the neighborhood. So he has your addresses, and when he sees the letter for a certain address, he will go to the house and deliver the letter. The same with APIs. Whenever the browser, or in this case we will use Postman, detects that we want to access that address, we will just deliver in the corresponding method that we are going to configure here. So we will have animals. So the group means that whatever methods that we decide to create, we don't need to put this prefix, it will always have. So let's define a get for all of them, and we will use our asynchronous zoo service method, our asynchronous method, that will have, actually we just need this. We just need to await the zoo service dot get all animals from zoo async. And these parentheses are redundant. There, we have it. Let's try to run to see if everything is okay. Seems like we have an error. Let's see what it is. Oh, of course, we didn't use the dependency injection for app DB context. So let's do it. We have to go here and in the documentation of Microsoft, we know that we have to do like this. AppDB context, that is the name of our class, and then we always have the options that we want to use, and the options use SQL Server, and then we want a connection string for our database here. So we know that is a local host. So I will put this and we'll be right back. There we go. We have our connection string to our local host, database master, user ID, our password, encrypt, and trust certificate true in order not to have security issues. So let's test it now. It runs. Awesome. So it runs in localhost and in the port 5284. So let's now use the Postman to simulate HTTP calls. So it's the 5284 and this is the route. Like we just knew, and it's a get. And it brought an empty list because we don't have data yet in our database. So let's build a method to post animals. So app.map post, and let's put like a query parameter, a URL parameter actually, and add. And then let's add by name, because as you can see by the movement type we just need to put the movement type, and it always deduces its name, so we don't need to put the name. So we use the name for the movement type, and then we use again the ISO service, and then we will add some logic here. So in the switch we have here an improvement from .NET 8. Before we will need to do like switch. What is a switch? A switch is to avoid multiple else if chains and to be more readable and to have also a default option. So let me explain. So switch, and if the name we receive case lion. Let's put to lowercase, so that doesn't matter which letter case we write in, it will always match. Case lion, then we will return, not return, actually let's declare here var animal a. In case we receive lion, a equals to new lion, and the movement type is walking. And we want to get out of this case because when we don't want it to go to the next case. If we don't put the break and break the cycle, we continue and he will do the logic for every other case. This can apply for every other cycle, like for loops, while loops, for each, etc. So in case tiger, a equals new tiger, movement type dot walking, and case eagle. Oh, we forgot the break. Our variable will have new eagle, the value, and movement type flying. And if the output doesn't match any of these, we put default and we just put in return a bad results, bad requests, animal name not known. And then we just proceed with the code. Now, .NET 8 introduced a way simpler way to use the switch. Now we can do the pattern match that is way simpler. So let's do like this: animal new animal equals to name to lower switch and then lion lambda new lion movement type walking. Pretty simpler, huh? Tiger and eagle that is flying. And then for any other case, this is similar to the default, the underscore. We just path. Actually, since path request is a different type, we'll make this nullable. What does this mean? This means that the animal, a reference type, can be null, can have no value, so the memory is not allocated for it. So null. That will allow us to do some verifications. Now we want to check if the animal is null. If the animal is null, we won't create, otherwise we will let the animal. So if new animal is not null, then let's check if it was added before. Let's check if it was added and call the zoo serve, because the zoo service will do that behind the curtain. And animal to zoo new animal. then if was added, then we return results dot created and let's put here the new animal. And the path that it used. Animals, name, and because the created requires the URI and the value that we passed. Else, but we don't need since this is a return inside the if and would get out of the method, we would return results dot bad request animal already in zoo. And if the animal is null, means it's not valid, we return a bad request animal does not need to be saved. Let's say that only the tiger, lions and eagles need to be saved and rescued to the zoo. And now we have an issue here, because if we return this kind of objects, he doesn't know how to process it. It will be very strange. So let's try it for you to see what I mean. Let's put a post and tiger animals tiger add. I think I didn't put correctly. Oh, I think I know what it is. So we have to hide animals and maybe call it like this. And there we go. We created. But the movement type here is 0. Why is that? It's because the enums here. Where is the enum? The enums here, although they are text here, they are not interpreted as text. They are interpreted as an integer. And to be interpreted as a text, we have to add something in the program. So we have to deserialize them in JSON, as JSON actually. So let's do the following. JSON serialize type of, and we have to serialize a list of animals and just an animal, and internal partial class app JSON serializer context. This is just a way that you have to serialize your content. You don't need to know this by heart. So we need to install the JSON package and package system.text.json. And use here using system.text.json. I think this is it, right? Or no? Oh, not interface, internal. Okay. What is a partial class? No, we don't need this. What is a partial class? A partial class is a class that can be divided in multiple files with the same name. So for example, I could declare this class multiple times with multiple different code by saying that this is a partial class. So now it should be okay. Let's run it again. And let's check the database. It is tiger walking. And let's see if the answer comes in JSON. Animal already in the zoo, of course. Eagle. Movement type 1. Still not. So we have to change this. So let's go to the enum and declare there is a really minor thing that is very important that we need to declare. It's JSON converter and type of JSON string enum converter. Again, you don't need to know this by heart. This is just a detail. So now it should work. We added the eagle, let's add the lion. And there we go. It converted the enum to its name by using this tag. So now we have to go back to our program and we want to get by movement type. String movement, we type in the movement type that we want, and of course the zoo service by dependency injection. And we will need to check. We will need to check. What will we need to check? If movement type let's put move type so that it doesn't have the same name as this one equals to movement type switch, and then if we type flying to search by flying, we will convert to flying, and if it's by walking, we convert to walking. Otherwise, let's set the default to null. And why do we need to convert what do we say from string to the enum? Because the method that we declared, so if movement type is not null, if it has a value, so if it mapped correctly to either flying or walking, we will call the service that uses the enum move type. And since it's an enum, since it receives a type that is not nullable and we are dealing in nullables, we have to get the value because it might be null. And then we check if the list of animals that we receive is bigger than 0, then results okay, and the animals, and we have to return here, otherwise we return not found, or actually, yeah, not found. No animals found with that type of movement. Let's put in here. And like this. Oops. Oops. What is going on? Okay. Okay. Now in the database, what do we have? All the 3 animals. Let's test it. So let's get all the animals. There we go. We have here the eagle, the lion, and the tiger. And let's search by movement type. So let's see if we put flying. Oh, actually, let's put here movement type to lower in order to accept any case of letter. If we put flying, it means we only should receive the eagle. And if we put walking, we should get the tiger and the lion. And there you go. You have a full API, and now you know the basics and a bit of the intermediate concepts of .NET 8. And there you go. That wraps up our tutorial on .NET 8 Crash Course. I hope you found this project helpful and that you learned something new along the way. If you followed along, congratulations on completing the project. Don't forget to like this video if you enjoyed it, and consider subscribing to the channel for more programming tutorials and projects. If you have any questions, suggestions, or just want to share your own version of the project, drop a comment below. I'd love to hear from you. Thanks for watching and happy coding. See you in the next video.